Okay, now we're going to talk about group theory problem 5 from the August 2013 qual. So this problem says, let F be a finite field with 3 elements, and let SL2F denote the 2 by 2 invertible matrices of determinant 1 with entries in F. So now we want to determine what the size of SL2F is, and next we want to show that SL2F has a normal CLO2 subgroup. So the proof of part A goes like this. We're going to claim that the size of SL2F is equal to 24. So to prove this claim, what we do is we notice that GL2FP, the size of the general linear group of 2 by 2 matrices with entries out of FP, is equal to p squared minus 1 times p squared minus p. This is because the first column vector has to not be a 0 vector, so this gives us p squared minus 1 many options for how to arrange the first column vector. And then the second column vector can't be the first column vector. So this means that there's p squared minus p many options for the second column vector. So now for the finite field of order 3, this means that the size of GL2F3 is equal to 3 squared minus 1 times 3 squared minus 3, or in other words, 48. So there's 48 elements in GL2F3. So now we're going to consider the map, the determinant map, from GL2FP into FP star. So this map is on 2 because we can just take the matrix x0, 0, 1 for any x in FP star, and the determinant of this map will always be x. And similarly, it's also a group homomorphism because the determinant of m times n is the determinant of m times the determinant of n, which is a well-known result from linear algebra. So this map has, and this map will then have, because it's a group homomorphism, it'll map to all the things which are the identity element in FP star, and that element is 1. So the kernel of this map is all the matrices which have determinant 1. In other words, this is SL2FP. So by the first isomorphism theorem, GL2FP mod SL2FP is GL2FP mod the kernel of this determinant map. And this is isomorphic to FP star. And FP star is equal to FP minus 0. So the size of F3 star is 2 because this is 3 elements minus the 0 element, so there's 2 elements there. And GL2F3 has 48 elements. So this means that 48 mod the size of SL2F3 is equal to 2. And so then this means that SL2F3 is equal to 24. The size of SL2F3 is equal to 24. And so this concludes our claim and proves that SL2F3 is of size 24.